Hello, so welcome back to this YouTube channel. Proceeding with our introductory classes in statistics. So today we'll be talking about the Ogive, which is otherwise known as a cumulative frequency graph. Okay, so it's just a graph that shows the visual representation of cumulative frequency of a data set. Right, it's like a frequency polygon, just that while frequency is to frequency polygon, cumulative frequency is to the Ogive. Now, how is the Ogive sketched? Right, so it is sketched by you know plotting the cumulative frequency of the data set against the upper class boundaries. So it is sketched by plotting the cumulative frequencies of a data set against the upper class boundaries. So how do you find cumulative frequency? It's not difficult. Okay, so since it's our frequency, cumulative frequency is going to start from the very first frequency, which is 2, so we call it CF. And I'll be doing this 2 plus 5, 2 plus 5 is 7, 7 plus 6 is 13, 13 plus 15 is 28, 28 plus 12 is 40, and 40 plus this 5 is 45. Now, how would you know if you're right? The sum of your frequency must give the last number on your cumulative frequency table. So what do I mean? 2 plus 5, 7 plus 6, 13, 13 plus 5, 28, 28 plus 12, 40, then sum of your frequency is 45, is equals to the last number on your cumulative frequency table, or column rather. Now next thing is going to be our class boundary, CB. So 0.5 to 10.5. I think you are pretty much used to this now. It's looking sweet and easy. 20.5, 20.5 to 30.5, 30.5 to 40.5, and 40.5 to 50.5, 50.5 to 60.5. So we are literally sketching CF against the upper class boundaries. So when you look at your cumulative frequency, what is the lowest number? The lowest number is 2, the highest number is 45. So what scale should be used? Because we have 1, 2, 3, 4, 5, 6. We have to represent 6 numbers at least on our cumulative frequency graph. Okay, so I think maybe 2 centimeter to 5 units, right? So we have 5, 10, 15, 20, 25, 30. So we'll be having like 9 numbers that way. Is it okay? Or use 10? 10, 20, 30. No, 10 will be too small because we have 2, 7. Okay. Should we use, let's just use 5. Let's just use 5. There's no problem. So here is our CF. Remember, here is the upper class boundary. So 0. 5, 10, 15, 20, 25, 30, 35, 40, 45. Yeah, we tried. Then the upper class boundary, 10.5. Okay. Now, there's something about this because the cumulative frequency graph must start from the x-axis. Alright, so for the very first interval, we also pick the lower class boundary. And let me kind of explain what I mean. So let's say we are using our 10.5 normally, and we are going to 60.5. Okay, here you have 10.5. It's not even too much. 10.5, 20.5, 30.5, 40.5, 50.5, 60.5. Now, if we start this, upper class boundary of 10.5, the cumulative frequency is 2. So maybe 2 around here, small. Then 20.5, 7. 7 is still before 10. Maybe around here, 7. 30.5 is 13. 30.5, 18 here. 40.5 is 28. 28. 28 around here. Then 50.5 is 40. 40, 50.5 is here. Okay, and then 60.5 and 45. 45, 60.5. Okay, 40.5 and this, somewhere here. Now, if you want to sketch this graph, you are going to be having something like this. But the thing about cumulative frequency is it must start from the origin. No, it must start from the x-axis, not origin. That's why the first class boundary is also included, the first one. So you have, and because the first class boundary is included, so 0.5 is around maybe here. So because 0.5 is not even on the graph, normally, so we assume that the frequency is 0. It's not there now, so the frequency is 0, right? So this is like, which one is 0? So x is, the x-axis has 0.5, this person has 0. Understand? So we just extend this guy. Does it make sense? So 0.5 here. What am I doing? Oh, I've erased. 10.5 is 2. So around here. 20.5 is 7. And then this one is 0.5 here. So I was looking to doing, so let me just use a red, so it's a lighter marker. Something like this. Yeah. It's manageable. Okay. First, you start from the horizontal axis. So you're done. This is how to like construct our ogive, right? 60.5, 45. That's all. So the next thing that we have to do now is an assignment. Here comes the assignment. Viewing time in minutes, the number of students. As I believe you know what the frequency is normally. Okay. So viewing time minutes, you have 300 to 299 minutes up to 1100 to 1199 minutes. So the first frequency is 14, 100 to 499, 46 students, 500 to 599, 58 students, 600 to 699, 76 students, 700 to 799, 68 students, 800 to 899, 62 students, 900 to 999 minutes, 48 students rather, 1000 to 1099 minutes, 22 students, 1100 to 1199, 6 students. So the first question is for each class interval, calculate the percentage number of students. It's not hard. 14 divided by the total, that's 100 over 1. But make sure that you write your formula. That also takes marks. Then B, construct the ogive of the distribution. You know what to do. Find your cumulative frequency and then find the class boundary, do the needful. And C, which I didn't mention at all, state 2 uses of an ogive. So browse, research, and you also read 1 or 2 things about it. You even know why do we even construct an ogive in the first place. Okay, so thank you so much. The next series of lessons should be looking at the measures of dispersion, measures of central tendency, some beautiful things there, not those kind of things you're used to, right? Beyond the things you're used to, some very nice things. And then enjoy this passion and keep on moving to moment to curtois or whatever it's called. Curtosis, yeah, I don't know, yeah. Curtosis at on and on. Thank you so much for attending. See you when I see you again. Have fun.